All right, so we're going to do 4-3 tonight. I posted the practice sheets in, but I did not print it off. Therefore, I did not bring it with me. Therefore, I do not have one to give you. What we're going to need to do is go from our quadratic equation of ax squared plus bx plus c to our vertex form. And that means we need to be able to go from here to f of x is equal to x minus h squared plus k. We want to go from the quadratic format, quadratic equation to standard form, into the vertex format. And I know it's everybody's favorite. We're going to do that by completing the square. So I'm going to take the first one. I'm not going to use one of the problems on your paper. I'm just going to make up one so that things stay kind of nice and easy to start out with. Once I get it in vertex form, then these are the questions that I got to answer. But the majority of it you've been doing and you know. I know it looks like a lot, but you know domain and range. And your vertex is going to give you this information. So we're going to start with f of x is equal to x squared minus 4x minus 12. So now I'm in my quadratic form. I'm in my standard form for the quadratic equation, and I need to change it into my, I think I need somebody to mute at home, please. I'm going to start with completing the square. Remember, b divided by 2 squared, right? So what's my b in this one? So I'm going to say negative 4 divided by 2 squared. And that's going to give me negative 2 squared is going to be 4, right? All right. I want a trinomial square. I want to have that x minus h squared. So I'm going to take my form here. I'm going to say x squared minus 4x. We'll move that minus 12. Now, guys, I am not working on two different sides. You know, when you're solving equations, if you add 5 on this side, you got to add 5 on that side, right? Well, this time, I'm staying right here on this side. So even though I want to add 4, I don't get to just throw numbers into the equation. I can't just change it, right? So when I add 4 here, I got to turn right back around and subtract it. If I do plus 4 minus 4, have I really changed my equation in any way? No. But what I have bought myself is this section right here. Because I can write that as x squared, no, not x squared, x minus 2 squared, right? What can I multiply that would get me a positive 4 and add up to a negative 2? Wouldn't these three right here, this trinomial, factor to x minus 2 times x minus 2? So that gives me my x minus 2 squared. So now I've got this part right there. I've got my x minus 8 squared. And then I have minus 4 minus 12. So that gives me minus 16. And I've got it in my vertex form. H and K are my vertex. So my vertex for this equation is 2 and negative 16. How bad is that? You either really, really don't care, or you're like, I don't know what she's doing up there. No? All right. Have we got it all written? Okay. So I'm going to say, let's try that same thing. We're going to get to answering these questions here in just a second. But I'm going to try that same thing with, let's do R47. We've got x squared plus 2x minus 8. That blue is not showing up. Dadgummits. You guys aren't seeing me doing any writing, are you?
No, ma'am. I was just about to say that.
Okay. Let me try opening this guy up. That's going to show up. Oh. It's negative 2 over 2 squared. Negative 2 divided by 2 squared. Negative 1 squared gives me a 1. Right? So in this equation, about right there, I'm going to insert plus 1 minus 1. So I'm going to say f of x is equal to x squared minus 2x plus 1 minus 1 minus 8. So far, so good? All right. Now I'm going to focus in on this trinomial right here. What can I multiply to get a positive 1 that will add up to a negative 8? How will this guy right here factor? Now the b is negative, so I'm going to say x minus 1, right? So now I've got x minus 1 squared minus 9. Okay, so that's my vertex form. F of x is equal to x minus h squared plus k. For this problem, my vertex is the h, k. So be careful now. Remember when you're doing your transformations. If I go x minus 1 inside the function, that's going to shift me to what direction? To the right, yeah. So that's going to be a positive 1, right? That vertex is 1 and negative 9. My axis of symmetry is going to be x equals h. So whatever is there is going to be your axis of symmetry. So on this one, when I ask you for axis of symmetry, you're going to say x equals 1. If I just looked at this and I said you needed to graph that from 0, 0, where would your vertex go? Because it would start here at y equals x squared. We start right there, right? There's my vertex at 0, 0. This negative 1 is going to shift at 1 and down 9, right? So now I'm not even going to try. Now my parabola is down here, and my vertex has symmetry with that x equals 1, right there. So what is my axis of symmetry? X equals 1. What does it mean to be concave up or concave down? Yeah, exactly. Now, how do I know if I'm concave up? Yeah. A is going to be positive. That's going to make my graph go this way, right? I got that U shape. If I'm concave down, I'm going to have a negative A. So if I look at my A, remember your quadratic is ax squared plus bx plus c, right? My A is positive. So that means in this problem, I am concave up. Now, since I'm concave up, and I'm going to have this parabola that decreases, 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 comes to a point, and then starts increasing. So would that point be a minimum or a maximum? Do I have a lowest point or a highest point? A lowest point. So I have a minimum, and that's going to be where? At y equals negative 9. See, your Vertex has already answered 2 of those questions. All right, here's the hard part. Domain. It's a quadratic equation, right? Now my numbers are going to have to get big because it goes pretty slow, but eventually that parabola gets wider and wider and wider and wider. My domain, every day, all day. Whoop, on the wrong one. All real. I don't care if it's concave up, concave down. I don't care if it's been vertically stretched, horizontally stretched. I don't care if it's shifted left or right. If it's x squared, your domain is all real. Okay? So that's the answer every time. All real. If it's x squared, y equals x squared is your parabola, and your domain will be all real. What about your range? You would have a minimum point. So is my range going to go below this right here? So what's my least range going to be? -9. And since it's concave up, it's going to be from -9 to infinity. All right, y-intercept. You're looking at it. If I'm at the y-intercept, if I'm on that y-axis, what's my x? 0, right? So if I come here and I've got a 0 squared minus a 2 times 0, what's my y going to end up equaling? Good. So my y-intercept is going to be 0, -8. And how do I find my x-intercepts? What's the first thing you ever did with a quadratic equation? And factor it, right? Okay, so I'm going to say x squared minus 2x minus 8 equals 0. Can I factor this one? Is there something that's going to multiply to a -8 and add up to a -2? What can I multiply to get 8? Okay, good. So I'm going to say x minus 4 times x plus 2. How did I know that the bigger number would have the minus sign on it? Yeah, you got more negatives because you know your b is a negative. All right, please don't forget that last step. X minus 4 equals 0 and x plus 2 equals 0. So my solutions are 4 and -2. So my x-intercepts, 4, 0, and -2, 0. So it's a lot of questions about one, but the answer, once you get it in that format, you kind of got that answer looking at you for most of it, don't you? Think that's going to be bad? Too bad. All right, let me see if I can. So let's try 43, x squared plus 2x. Yes. Mercedes. Ryan Hall, race. B over 2 squared. So what's my D over 2 squared gonna get me? 2 over 2 squared is 1. So I'm gonna say x squared plus 2x plus 1 and minus 1, right? Now what can I multiply? That will get me a 1 and add to get me a 2. And I still have that minus 1. So here's my vertex form. F of x equals x plus 1 squared minus 1. And don't forget, your format is x minus h, right? So when you have an x plus 1, what does that tell you about your vertex? If it's plus in here, then it's going to be a negative, right? Because the only way that this sign changed to a positive is if I ended up with that double negative. All right, so my axis of symmetry is x equals -1. Concave up or concave down? Is A positive or negative? Up, right? Because my A is positive, so I am concave up. If I am concave up, that tells me, do I have a minimum or a maximum? Minimum at y equals -1. Domain? Range. -1 to infinity. Okay? What's my y-intercept? If I had to put a number back there for C, what number could I put? Well, if my x is 0, what does y equal? 0. So I've got 0, 0 for my y-intercept. Now, if I go to factor this guy, So I say x squared plus 2x equals 0. Don't have that trinomial, but I do have a common factor, so I'm going to say x times x plus 2 equals 0. So that gives me x equals 0, or x plus 2 equals 0. Now I don't have to write the 0, 0 one again because I've already got that, but I also have negative 2, 0. Not too bad. Kind of messy. Now sometimes when you get to those x and y intercepts and you got a quadratic that doesn't factor, what do you have to fall back on? If it don't factor, what do you need? What will always factor quadratic? The quadratic formula. Do you remember what that is? Let's make sure we have that. Negative b plus or minus over 2a, right? Sometimes when we go to factor to get those x-intercepts, we can't. All right, so completing the square is one method. I'm going to go through with another method. Couple of problems that have a different way of doing it, and what way am I going to want you to use? I'm going to want you to use the way you think is better. So I'm going to do 48 x squared minus 2x minus 3. Now instead of completing the square, I'm going to use what they call that vertex formula. And that's negative b over 2a. Now this is my x. That formula is only going to get me my x, okay? So what's my b on this one? So I have negative 2 over 2 times 1. What's that going to come down to? 1. All right, so my x and my vertex, my h, that's a 1. How can I find out what my y is? Well, I have y equals x squared plus 2x minus 3, and do I have an x? Yeah. So I'm going to plug it in. And I'm going to say y equals 1 squared minus 2 times 1 minus 3. So I've got 1 minus 2 minus 3. That's going to come down to a negative 4. So my vertex is going to be 1, negative 4. So to write that in vertex form, I'm going to say x minus 1 minus 4. What's my axis of symmetry? Always the x, okay? Concave up, concave down. Good. My A is positive, so it's a concave up. That means I have a minimum at y equals -4. My domain is all real, and my range is -4 to infinity. My y-intercept is, it's looking at you, 0, -3. All right, then I got a factor. Will that factor, or do I need to use my quadratic formula? Can I get a factoring out of that? Can anything multiply to get a -3? Why are you not working all of a sudden? There you go. X squared minus 2x minus 3 equals 0. I can do x minus 3 and x plus 1. Don't forget that last step. X minus 3 equals 0. So x equals 3. X plus 1 equals 0. So x equals -1. So I have 3, 0, and -1, 0. Not too bad. Let's try 50. X squared plus 6x plus 9. Use your completing the square. Find your vertex. So if I have negative b over 2a, that means I have negative 6 over 2 times 1, right? ax squared plus bx plus c. So what's negative 6 over 2? So that's my x. How am I going to go about finding my y? Plug it into your original equation, guys. Negative 3 squared plus 6 times negative 3 plus 9. Positive 9, negative 18, positive 9, y equals 0. So my vertex is going to be negative 3 and 0. So what is my vertex form going to look like if my vertex is negative 3 and 0? And that's going to be a plus 3 because that's a negative, good. And there's no y, right? It's a 0. So just x plus 3 squared. Axis of symmetry, x equals negative 3. My a is still positive, so I'm still concave up. That still gives me a minimum. Y equals 0. Domain is still all real. Range 0 to infinity. Y-intercept is 0, 9. And what can I factor? Get a 9. That will add to a 6. So x-intercept is negative 3. Yes? All right, now, when it comes to problems, can I clear screen or we still? That are a is greater than 1 or negative. We're going to do one of these negatives here. Use that formula. When you have a negative 2, you can definitely complete the square. Let's look at 53. I have f of x is equal to negative 2 For me to complete the square, I'd have to factor out that negative 2. Because my first term has to be a square number, right? And negative 2 is not a square number. So I'd have to factor that out. So that would start looking like negative 2 x squared plus x. And then I'm going to have that minus 3 over here. And I'm going to have to complete the square with a 1. So now I've got a fraction. The goal is to get the easier path to the answer. That's why math even exists. So anytime you look at this problem, your problem, and your A is more than 1, use your formula, negative b over 2a. X equals. So let's get one more vertex in here before we move on to our next. Let's find the vertex of this. So negative 2 over 2 times negative 2. What's that going to reduce down to? Perfect. Okay, so that's my x. My x for my vertex is going to be 1/2. Then I have to 1/2 squared plus 2 times 1/2 minus 3. So now I have negative 2 times 1/4 plus 1 minus 3. So that gives me a negative 1/2 minus 2. It's 2 with the denominator of 2. So what do I get? Negative 5/2. Yes? Okay. All right. After that, we have to take a vertex and a point, and we have to get back to the quadratic. So we got to work everything we did just backwards. Now we had the equation, we didn't have it, we had something like it, x squared, and we can factor that down to the x minus 6 times x plus 2, and my solutions are 6 and negative 2, right? And I can give you the solutions to a quadratic and you can plug them in. Like if I said, okay, the solution to the quadratic equation is 3 and 4. Tell me what the equation is. You'd go right back to x minus 3 times x minus 4, FOIL it out, and get that equation, right? Okay, so that's what we're going to do here. Now we're going to have to figure out what our A is. So all we're going to do is take what we've got. My vertex is 2, 3, and my y-intercept is 0, negative 1. First piece of information I got to find out, I got to check is what's A. I'm going to use f of x is equal to a times x minus h squared plus k. First step I want to do is I want to make sure that that a, what number that a might be. So this f of x, that's my y, right? And what's my h? X minus 2. And my k is plus 3. And I still have too many variables to figure out what my a is, but can I replace some more of those variables with information I have? Do I have an x and a y? What's my y? Equals a times 0 minus 2 squared, plus 3. So negative 1 equals to a times negative, nope. That's not going to be a negative 4, is it? A times 4 plus 3. Subtract that 3 from both sides. And negative 4 is equal to 4 times a. Divide by that 4. And a equals negative 1. Did we want our a to equal a negative 1? Look at our graph. Right? It's concave down, so I needed a negative 1 for a. That makes sense, doesn't it? All right. Can I erase this? So now all I'm going to do is go back up and fill in f of x is equal to negative 1 times x minus 2 squared plus 3. FOIL out, I've got negative 1 times x squared minus 4x plus 4 plus 3. So far, okay? All I'm doing is breaking out what was here. Now I'm going to distribute, so I've got negative x plus 4x minus 4 plus 3. Sorry. Negative x squared plus 4x minus 1. And does that hold out with my graph having a y-intercept of negative 1 here? So there is your quadratic equation. Given a vertex in one point, you can get back to the equation that creates this. All right, why don't you try 63 here. My vertex is 1, negative 3, and I have the point 3, 5. Go after A. Plug all your information in, find out what your A is going to be. Then my vertex. You know what else can I put in? Instead of Y, A times minus 3. So 5 equals A times 2 squared. I'm going to add that 3 to both sides. And 8 equals 2. 2 squared is 4. Divide by that 4. And A equals 2. Okay? Now I'm going to go back up to this point right here and plug in that 2 for my A. So when I FOIL out x minus 1 times x minus 1, x squared minus 2x plus 1 minus 3. 2x squared minus 4x plus 2 minus 3. And my equation is 2x squared minus 4x minus 1. Yes? Okay. All right, just there won't be a weekly quiz this week. So your next one on chapter 4, and that's going to be 4.3 and 4.5. You all have the schedule and the list of units, right? If you don't have the one I gave you in paper copy, it's in that announcement somewhere. Things are getting buried now as the semester moves on, so you might have to scroll down a little bit. You should know when our test dates are. You should know what it's covering. Our next weekly will be on the 5th, I believe. Something like that. I'll open it up next week. I'll probably open it up this weekend. You can take it up until like we get through next Wednesday. Okay? All right. Y'all have a good night. Anyone at home with any questions?